Good evening, ladies and gentlemen. Welcome back to the fourth day of our webinar series organized by the GAP Research and Development Center in collaboration with the India Sri Lanka Foundation. We are delighted to have you with us again, and today's topic is biomimicry in construction, conducted by Professor Janaka Ruwanpura. We will explore how biomimicry principles can revolutionize construction practices to create more sustainable and efficient building. It is great honor and pleasure for me to introduce our resource person for today, Professor Janaka Ruwanpura. So let me give a few minutes to introduce him. Professor Janaka Ruwanpura served as a Vice Provost and Associate Vice President of Research at the University of Calgary for over 11 years, and he was recognized as one of the top 25 Canadian immigrants in 2022 and has held prestigious positions including Executive Chair of APLU's Commissions of International Initiatives. Professor Ruwanpura, a former US Fulbright Scholar and Canada Research Chair in Project Management Systems, has made significant contributions to project management and construction through his research and publications. And also, he was the founding director of the Center for Project Management Excellence at the University of Calgary. During his tenure, he initiated collaborative degree models, customized training programs, and global research initiatives in China and Mexico. And also, he secured substantial funding for research and infrastructure and established numerous international partnerships. His effort has earned New Calgary several awards, including the CBIE's Comprehensive Internationalization Award and APLU's Platinum Institutional Award. And he also developed the International Partnership Assessment Rating Index, which received the Catalyst Award for Innovation from CBIE and the Innovation Award in Internationalization from AIEA. So I cordially invite our Professor Janaka Ruwanpura to share his valuable thought in this webinar. Dear sir, over to you.
Thank you, Sandeepa. Good evening to everybody who is connecting from Sri Lanka, and those who are connecting from anywhere else. Good morning and good afternoon to you. Let me share my screen. So I'm actually going to add a little bit of a more broader nature before I talk about the construction side in terms of how the nature-based or nature-inspired engineering solutions for a sustainable and regenerative future, with a focus on how biomimicry in building and construction projects. And I want to recognize, we are from University of Calgary, as well as I'm currently is the president of the Canadian Network of Sri Lankan Academics that we like to sort of collaborate with gapHQ on this as well. So if you go through the nature-based solutions for building construction, right? When you looked at it, there are a number of different ways of that you can see biomimicry in terms of nature mimicking, that you can see opportunities. Then there are things that are related to adaptive reuse, nature respecting. There are things related to eco-conscious materials that are being used for construction, which is a nature sourced. We are also have seen the nature integrating with living buildings. Biophilic design is also in terms of nature incorporating, and then the green infrastructure, which is a nature utilizing, and then regenerative design is a nature regenerating. And I will go through each one of them very briefly. So if we look at biomimicry in terms of nature mimicking, where biomimicry involves designing buildings and structures, that would look at it's mimicking nature's forms, functions, and systems, right? It is to ensure that we learn from the nature, and so that we include the designs and processes to solve the human challenges that we are facing today in terms of building construction. The good example is the very famous project that was done in Zimbabwe called the East Gate Center, which is inspired by the termite mounds for natural cooling. You can see a number of good YouTube videos on this project, and then how biomimicry is included in there. Whereas when you look at in termites in Zimbabwe or anywhere else, I mean, you can see that they can create mounds. Now in this particular case, they're called the gigantic mounds, where they farm fungus, which is their primary food source. So the fungus must be kept, as you can see from the slides, at exactly at 30 degrees, while the temperatures outside range anywhere from 1 degree to 40 degrees during the day, right? I mean, you can look at, the Zimbabwe's, weather, a little bit closer to Sri Lanka, but not to the same extent in terms of the nighttime. So these termites achieved this remarkable feat. I mean, imagine nature, termites, by constantly opening and closing a series of heating and cooling vents throughout the mound over the course of the day, right? So that's the inspiration that have been taken by the teams in Zimbabwe, where they have taken how it can be used in the building structures in a similar way for, first of all, the design and then the construction part of it. Similarly, if you look at biophilic design, how do we look at nature incorporating? Again, we cannot talk about construction without talking about engineering and design. So therefore, I'm combining both engineering, design, and the construction here. So in this particular case, the design integrates the natural elements, right? The materials, the forms, into looking at the built environment, where the occupants can be connected very closely throughout the day with the nature, right? And this is where you can use various elements related to the use of plants, natural light, and organic shapes, where then water features. So example that I'm showing here is a building in Amsterdam where it incorporates extensive, where they look at the extensive indoor greenery, and then maximizes the natural light, right? I mean, these are great examples that you can think of in Sri Lanka. So if it can be done in Amsterdam, that can be done very easily in Sri Lanka. I wish I had the chance to see this one when I was in Singapore earlier this year. This is the biophilic design where nature incorporating. So Park Royal is a hotel chain, a very famous hotel chain, where they have lots of different hotels in Singapore and elsewhere, where it's a fully a hotel in a garden type of a concept, incorporate extensively the natural phenomena of greenery into its facets, walkways, and common areas. So it actually includes very large contoured garden terraces that, as you can see from the picture, waterfalls, and then having that lush greenery where you can actually connect it with a nearby park into an urban hotel environment, right? I mean, if you think about it, in Sri Lanka, we probably have various examples that uses very similar concept of that. But the interesting thing is that when you look at the design aspect of it, it provides the aesthetic benefits, right, to enhance the concept of the urban environment, promote the biodiversity, and then when you look at in terms of the appearance perspective, that it helps to attract customers, attract the guest, maybe finding an environment where that would be beneficial for both visitors, guests, and the hotel staff. Next example is the green infrastructure, where nature utilizing, where there you can actually use as natural or semi-natural systems for ecological, economic, and social benefits. I mean, here we talk about an example where it includes the green roofs, rain gardens, and permeable pavements that manage the stormwater and create a green spaces, right? Now, the challenge here is that how do we amalgamate the design concepts with construction so that it can manage very well, that the construction can be buildable, constructible, with less maintenance after the construction is done, right? Because sometimes I have seen examples where the designers design structures, it's so beautiful, pleasing, but difficult to construct, right? And sometimes once the construction is done, there are a lot of maintenance issues. And then if you do that, then you lose the concept, the whole sustainability of that, right? This example is from the New York City in the United States, where it's an elevated park built on a disused railway line. So when you look at from the sustainability perspective, that's a really a good example of reuse. This is close to where I live in Calgary, Alberta, where, winter times, sometimes we go into minus 40 centigrade. Sometimes we go even below minus 40. But at the same time, during the summertime, sometimes our temperatures are even higher than Sri Lankan temperature. We can go up to about plus 35 centigrade. Can anybody please mute your microphones? Thank you. And at the same time, where I live, we have 333 out of the 365 days are sunny, right? A day can be sunny, but it could be minus 40, right? So this is an example of in a closer neighborhood where it's designed to be heated by solar energy, where the community's heating system comprises of solar panels and borehole thermal energy storage, where over 90% of the community year-round heating requirements are met through this solar energy, which is collected during the summer months and stored underground for use during the winter, right? A great example of sustainability. When you look at the nature integrating living buildings, where living buildings are structures, that are designed to function close to the built environment or the living organisms, where they are self-sufficient in terms of the energy use, the water use, with renewable energy sources, water recycling systems, and then use organic materials, right? And this is an example from the United States, in Virginia, designed to be energy neutral and water self-sufficient, which is actually a fantastic thing when you look at the whole idea about the sustainability. I could put this question to you. How can we use our eco-conscious materials? We are in a tropical environment in Sri Lanka, right? This is an example where within Asia that, that it uses the eco-friendly and sustainable materials that have, I would say less environmental impact, renewable, and from the nature, bamboos. Bamboos are available in Sri Lanka as well, recycled wood and natural fibers, right? So, and then it's locally sourced, supplied, so that it can have the commitment to using the low impact resources. This is a Sri Lankan example where I got involved in my younger days, the tea factory Kandapula, where using the adaptive reuse, which involves repurposing the existing buildings or structures for new uses, reducing the need for bringing new construction, new materials, and minimizing the environmental impact. So this is converting an old tea factory into a hotel where you have seen examples where various manufacturing factories have been used or warehouses have been converted into residential, commercial spaces, preserving natural resources and cultural heritage, right? So we actually have used many of the exterior features. We have actually used the windows from externally with some minimum changes or modifying some of them, but making sure that it actually kept the original intention of that, and then respecting the nature, and then adding the other features into them, right? But if you go back and think about the ISO standard of 18458, something is biomimicry if the function analysis has been made up with an available biological system, right? So these are kind of the theoretical principle behind that. Well, the biological system has been abstracted into a model, and the developed model has been transferred and applied to design a product. So then a product is considered biometric if all three criteria are met. So that's why when you look at from a, now add the word product, building. If you design and construct that one according to this criteria, then it actually benefit the purpose of having the biomimicry nature. So you may have heard this, but a lotus leaf is an example, something that is available in Sri Lanka. We can work at any scale from self-cleaning paint that mimics the microstructure of the lotus flower. So imagine in a high-rise building or a tower that mimics the termites mound ventilation structure to keep it, itself cool. At the same time, using the lotus a feature on the flower and then the leaf, where that it creates a self-cleaning window, self-cleaning walls, right? And those are the key at the end of the day. Before we talk about construction, it actually has that engineering design component that would be really beneficial for us to do the whole the concept of that. Okay. Now, in order for us to do these type of things, what are the challenges for advancing the biomimicry in building construction? Right. So these are 5 things that I have come across, and I actually wanted to work on this further with GAP as well, in terms of enhancing it further into a more R&D environment. But I'm going to talk about 5 things here. That there are some challenges in terms of technical and structural. There are challenges in terms of environmental and sustainability. There are challenges for economic and practical, conceptual and integration, and regulatory and approvals, which I will go through one by one, right? Now, this is a project in, I think it's a Gakin Tower in London, where there is a complexity in terms of design and construction that you can see here, that we need to take into consideration. So let me take it through some of those examples that I have noted here, where we need to sort of look at in terms of how we consider the connectivity with each one of them. Give me an example, please. I just wanted to take some of my notes into. I'm going to take a quick screen this thing, and I'll be connecting it back in a minute. Okay, so. So when you look at in terms of this design, where it's the key is that it actually can look at it's inspired by a Venus flower basket sponge, right? And then you can see from that picture that that the deep sea sponge has a like a lattice-like structure that provides both strength and the flexibility of that. So now imagine having that kind of a design and how that design is being into the construction side of things, that the challenges that we would go through in construction to maintain those design elements that are being built into that. So let me take back into my presentation. Right, so you can see that when you take a design like this one, like how do we ensuring that the design elements are, you can actually see several examples of that, right? It's a complexity in the design. And how do we look at the complexity in design is being constructed? How do you look at the limitations in terms of materials that are being adaptable to ensure that the design concepts are being very well maintained, right? And we also want to make sure that the structural integrity is maintained in a way that it would fulfill the requirements of the designer's challenges. Then you go into another example like the environmental and sustainability challenges. This is a Bahrain World Trade Center where the challenge is integrating the renewable energy generation, right, within the structure itself without compromising the original design concept of it, the original aesthetics of that. When you look at from like, a 360 view of that one to ensure that it would not kill the whole concept of the architectural and the engineering mindset of that, right? So the building incorporates, you can actually see it incorporates these three, large wind turbines between the two towers designed to take advantage of the wind flow. But when you look at from the actual energy generation has been less than the anticipated due to the variability of wind speeds and the difficulty of integrating the turbines seamlessly into the building operation. So this is a challenge. So you plan for something, right? You do all the calculations, but at the same time, when it comes to the reality of that one, sometimes it may be different than what you expected. Economic and practical challenges. So there's an example from Melbourne, Australia, where implementing innovative green technologies within budget constraints, right? But you can see that these facades have been designed to react to sunlight and wastewater recycling system. But these features contributed to the building's high sustainability ratings. It obviously get the rating, maybe getting the rating for the LEED buildings or whatever, than any other conventional buildings. But if you look at from the upfront cost, was significantly higher than the conventional buildings. And then the payback period, depending on the use of the building, maybe the energy use could be long-term. And then the question comes, is it economical as the initial investment, right? As you can see that I'm actually blessed to be both a professional quantity surveyor and a professional engineer. In my early days of my life, these are some of the challenges that I faced when I represented myself as a QS. Even working with, you might even not know, an architect, renowned architect like Jeffrey Bava, right? We don't talk about we were even scared to talk about the cost aspect of it, right? Because you're giving this opportunity for the designers and designers to come up with the best design on that. But then the challenges come in terms of implementing the project, because it may be upfront cost is pretty high, right, than a typical building. So this is an example from the United States where looking at the integration and the conceptual ideas, where integrating a range of biomimicry and sustainable features into a design, integrated design, where they have a living roof that mimics the hills of San Francisco, which is a beautiful area, and then also housing the local plant species and wildfire. Because when you look at from integrating the living roof with the buildings, other systems, water management, energy efficiency, and the design aspect of it now, here the biggest challenge is to make sure that we can construct it according to the design. But at the same time, don't forget that once you construct, how do we ensure that the people who are living in that structure in a building, that they would have less maintenance issues? If you look at building green roofs, even for houses, building green roofs to mimicking something else, that could create quite a bit of challenges when you are actually using that building structure. So you have to be very careful into the construction stage. The fifth element is where this is an example from Germany. How do we ensure that the regulators who approve these things would understand the innovative use of materials and systems that have not been in the building regulations in the past? So, for example, this building includes a bioadaptive algae facade that you can see from there, where it's a novel technology at the time of the construction, right? But when we looked at the regulatory process, was a lot of complications because there was a lack of existing codes in such a system, where additional documentation was required, the testing was required, the approvals was required, and then to compliance with the building standards and the safety regulation, right? So that's a challenge that I would see in terms of that. So what I have, this is something that I want actually sort of to say this one. I actually wanted to see whether that in the future going forward, right? I really wanted to work on a lot of research in these areas. If you take, for example, any one of them, right? Let's take this as an example, right? What I want to talk about is what are the specific challenges. So there are regulatory standards, which is a lack of specific regulatory standards for biomimicry materials and designs, leading to uncertainty and delay in approvals. Approval processes, lengthy and complex approval processes for new materials and methods, which can hinder the innovation. The code compliance, ensuring that the biomimicry designs comply with existing building codes and regulations that can be difficult due to their novel nature. What are the potential solutions that we can think of it? I'll talk about three things. One, regulatory frameworks. Developing a regulatory frameworks and standards specifically for biomimicry construction to provide clear guidelines. Second one is streamlining the approval processes, where you are creating a streamlined process to innovative materials and designs to facilitate a faster adoption. Code updates. Updating the building codes to include provisions for biomimicry in designs, ensuring that they are recognized and approved, right? I'm assuming that the audience probably have those who are working on research. So what are the research opportunities? One of them could be a policy studies where you are conducting research on the development of regulatory frameworks for biomimicry construction to support innovation. Second one is approval process optimization, investigating ways to optimize approval processes for new technologies to reduce the time and the complexity. Maybe a third example could be a code compliance type of research. We are studying how existing codes can be adapted and developing new standards to accommodate biomimicry designs, right? So that's the key, right? For example, look at the challenge. What are the potential solutions? Then how do we take this into a more research opportunities? Okay. Now, this is interesting. When I talk about the biomimicry and the nature, this is actually an AI generated building. Okay. So when you look at biomimicry principles for a proposed, let's say, engineering building for my university, let's say you look at the imaginary. So how do we ensure that these are being done in a way that biomimicry principles are being identified? So let me take you through this example and to talk about a few things in there. Okay. Number one, how do we adapt the biomimicry into the structure and the function, right? For example, can you see that the facade is inspired by the nature here, that it actually mimics the natural systems, such as the insulating properties of an animal fur that you can see from the white, or the self-cloning mechanisms of certain plants that you can see, right? In terms of the efficient air circulation aspect of it, the design could incorporate ventilation systems that emulate the efficient air circulation found in natural structures, like what we saw on the Eastgate example of the termite mounds or the bird nest that is in China, which maintain the stable temperatures without external energy inputs. So that's one aspect. Then we look at in terms of the energy, sustainable energy solutions. There are solar panels that can be included as the same example that I showed you. Integration of them also that it reduces the dependency on the non-renewable energy sources. The second one is the green energy technologies, so that the use of green technologies like the geothermal heating and cooling systems that can be used. Then when you look at in terms of the water conservation and management aspect of it, you can actually probably look at the rainwater harvesting during the summer, spring time. There are systems to collect and reuse rainwater for non-portable purposes like irrigation and flushing toilets. Efficient water use can be implementation of the water efficient features and appliances that would adapt to deal with the situation. You can see the green spaces there, where you can actually have vertical gardens or green walls that to improve the air quality, to contribute to the building insulation, reducing the heating and the cooling needs. We talk about the rooftop gardens in managing rainwater and providing additional insulation. And then you can talk about the use of eco-friendly materials. Maybe looked at what are the relevant materials with low environmental impact, locally sourced if possible, like the example that I showed you from the bamboo one. Adaptive and flexible design, for example, modular spaces. where you can actually configure to changing over needs over time, and then maybe look at the multi-purpose areas, um, smart building technologies, climate control, enhanced security. You can actually use the IoT integration and sensors, improve the building performance. Look at the building performance and comfort. Look at the cultural integration and aesthetics, right? So likewise, you can actually make sure that we can look at things in detail, right? That would build into a proper design that would help in looking at the construction becomes easier, right? Because we want to make sure that it, and that's why we are also suggesting, rather than going through a traditional methods of um, procurement on that, how does the designers and constructors can work together, right? Having a design done so that it would be a sustainable construction going forward, right? Similarly, let's assume that we want to do a building to University of Peradeniya, right? Again, this is an imaginary picture that I have used it in a way where we can talk about few things looking at your own environment. One is the natural ventilation, right? Because of the warm, humid climate, the building can prioritize the natural ventilation, comfortable indoor environment, that it can be, looking at the for facade design, large windows, open corridors with air circulation. You can look at the shading and the cooling aspect of it to mitigate the heat. That we have, overhanging roofs, deep verandas, shaded courtyards, and in terms of reducing the indoor temperature naturally. Integration with nature, right? So you can also design and blend with the lush greenery, similar to the environment, so that it promoting the biodiversity aspect of it. Sustainable water management, rainwater harvesting, which is quite possible, and it's quite essential given the rainfall in the region, so that the efficient water management systems would ensure the sustainability and reduce the building's environmental impact. We can think about bringing the locally suitable materials. That would also help. Again, look at the whole sustainability, social, economic, environmental, that it actually also supports the local economy, which reduces the carbon footprint associated with transportation, right? And solar energy utilization, right? So, a place like that one would be solar panels, key component of that, and look at a number of other things. So it's 8:10. So I've spoken for about 35 minutes. So I want to give a chance for any other questions that you have. So I'll stop my presentation and I'll repeat it again. So this is an integrative process. Before we talk about the biomimicry in construction, we need to look at the whole mechanism of making sure that we bring the nature-inspired opportunities into the design and engineering, right? Then it is easy to do the construction aspect of it. Before we talk about construction, I think it's critical that we look at the design and engineering and then build that integration between design and engineering and the construction. Sadeep, over to you.
Okay, thank you very much, sir. So, if you have any questions, so unmute your mic and ask the questions.
Please go ahead, Uber.
Yes, Professor, it's very informative and lots of new inputs on that. Just I think in the past history of Sri Lankan buildings or whatever, that the things are made, biomimicry has been used, I think, to a greater degree. So in the process that we took certain lessons from that and we started to build it. But with the misnomer of development, we saw certain buildings or complexes coming up without any consideration. And today, in the process to overcome that and to talk about sustainability, we are trying to mitigate those mistakes through the like solar paneling and so on and so forth. When we had the opportunity to bring daylight into the buildings and we had the opportunity to have crosswinds through the buildings, there are buildings which have been made that way. I think, as you said, Mr. Bava started doing it. My question is, do we have any institution to regulate that with such a lot of knowledge base that we have within Sri Lankan community? And because we heard in the presentations that we lack this, we have not done it, and how are we going to do it in the future? What is your thinking into the future? How can we bring about this as early as possible? Because we have to meet certain deadlines by 2030 in sustainability. I think we have, as a whole, Sri Lanka has not met even 20-30% of where we need to be.
Ubaya, thank you very much. It's a very relevant question. My blood pressure is going to go up now. Okay? Because we always trying to come up with short solutions. We just look at it, and you said it very clearly, one example about the solar panels, right? This is where the R&D culture of Sri Lanka needs to be improved. And I'm a Sri Lankan. I studied in Sri Lanka. And you can see from the back my logo, which is where we call by the Canadian Network of Sri Lankan Academics. One of the reasons why we build this network is to see how we can help, and based on what we have come across in this part of the world, to build a lot of collaborations in terms of academic research, service, support, leadership, rankings, reputation, all that stuff. So there is a need to properly set up in a way that we would develop some fundamental research capabilities within our university system. So in order for us to do that, we need the integration of the research system with industry, like, whether it's with these institutes like the Institution of Engineers, Sri Lanka Institute of Architects, the Quantity Surveying Institute, and everybody needs to be part of that. But not only that, the industry needs to be in place on that. So that means the government needs to provide the funding mechanisms, whether through National Science Foundation or whatever it is, to universities, so that we can actually have a proper mechanism of sustainable R&D funding to do that, so that it starts with a fundamental aspect of it, which leads to applications, right? So you saw that my slide about those 5 challenges that I indicated. I think I'm actually planning to do some research from this end to see, and then also to develop that same research culture in Sri Lanka, and then maybe collaborate with GAP to see how we can develop a fundamental research which leads to a sustainable applications. And I like your concept about the institute. I think there's a biomimicry research center within GAP as well. So to do in a more systematic way, it might take a longer time, but rather than we shooting ourselves and get into a quick solutions, it would be better to have a proper mechanisms of R&D that leads to application. It leads to more entrepreneurial opportunities in terms of materials, systems, construction methods, construction processes that can be done, right? So that's my sort of approach in terms of how do we bring a larger stakeholder group working together and investing resources to our local universities and connecting with organizations that are relevant to make it a more viable investment and opportunity for going R&D into more applications. That was my response on that. However, if you want to make it quicker, yes, we can do that. We can come up with elements from different areas and look at them and then come up with solutions where we can work with each of the industry partners and do that. But then if you don't think about it in a broader way, like for example, I spent some time on the regulatory aspect of it. There's no point we're bringing something, a new material, a new system. We don't have the infrastructure to really understand. If our regulators don't understand how that works, it's not going to go forward, right? It might have the delays in terms of approvals, right? Ube, a very good question, but we have a long way to go in terms of making it to a more solid plan.
Thank you, Professor. I think we require a complete overhaul of the system. Otherwise, we are not going to reach anywhere. Thank you very much for your inputs. Appreciate it.
It's called the system shutdown and restart.
Good evening, sir.
Good evening, Raja.
Sir, it was a pleasure listening to you the entire time. I've got something in my mind. How can we biomimic in tourism industry? What can we think of? What precautions or things that we can do to, actually make this biomimic a global thing?
I don't have much expertise on that. But recently I saw something that, in fact, I had communicated with Professor Janaka. We talk about the beaches in Sri Lanka. And I saw a news article that our beaches are not being rated, right? There's a system that actually rates the beaches in the world, and our ones are not done in a way. It's done by a third-party organization, right? So the key is every single aspect that I indicated, and we can actually use that one as part of the tourism to ensure that we build things, we enhance our infrastructure so that we can get attention from whoever wants to visit Sri Lanka to enhance the tourism industry, right? It's a different challenge. I think, it's beyond what I'm talking about, right? But I was actually, to be honest, Rajan, I was very surprised to see that news article that our beaches are not rated, right? And we proudly talk about our beaches, our beach is as an island. That's one of our key elements that would enable our tourism, right? One aspect of it.
Yes,
but we have to take the advantage of that. But again, I don't have experience on that, so I can't comment on that. But it was a thought that
the question which came out was because I'm a research scholar of tourism, and I've been with you for last 4 days, and it's the way things are being imbibed, and beautiful presentations and beautiful concepts which are coming in. So there was one idea of looking at something to do with the construction phase of the hotels, of the public places in which actually tourism dwells. So when we can, if we can have some kind of guideline towards that front, since it is a construction thing, and obviously hotel is or hospitality basically is a glamorous industry. So you need to do something with the pictures that we have seen. I mean, those pictures are obviously very good for the environment and all, but then the guest who is coming in the hotels or hospitality industry, when they pay a penny, they demand value for money. So that needs to look glamorous, and we need to maybe work on that kind of line, wherein it is air conditioned free, building, but glamorous at the same time. So maybe something towards that line what
Yeah.
was basically the question.
Yeah. Rajan, where are you
So
from? Where did you say you?
I'm from India, sir.
Yeah, that's what I
I'm
kind of, which
based
part of
in
India?
Himachal,
Where about it?
northern part of northern part of India. India, sir. Himachal, Dharamshala, McLeodganj, where
Yeah.
Dalai Lama is, or where the
Yeah.
cricket ground is.
Yeah.
So I come from that place.
We should connect back. I mean, so this is, and what you're suggesting is really a brilliant idea. There are a couple of beaches in India have been identified in the rating system that I was talking about, right? But
Yes, sir.
I have been to a number of other places. In terms of the tourism is really marked with the opportunities, and then what you're talking about in the biomimicry, there's so many different things that every single aspect that I mentioned that can be
Yes,
done
sir.
for the tourism and especially for the hospitality industry if we plan things more carefully. Okay, it needs to have that planning mechanism before we even talk about the design, right? Before we talk about the construction, so that needs to be built in there. But we should have a chat, and maybe Professor Anjit Disanak and I will have a chat with you. We can see what we can do.
Perfect, sir. It was nice talking to you, and looking forward to getting connected with you.
Thank you. Thank you very
Thank you, sir.
much. Any other questions? Yeah.
Sir, I'm from Sri Lanka.
Yeah.
Thank you very much for your very insightful presentation. I'm actually involved with tourism study program at the University of Colombo. So what we can see is our tourism, sustainable tourism development. The biggest challenge is market forces have not recognized how the application of sustainable tourism and environment green tourism can be applied. The most challenge is most of the people think that it is not profitable, and it is not sometime not running when they are running. Okay, they cannot get the fast cash for their development. So that is a bad image we have now. Would you like to suggest something for that one to correct? Because otherwise, the business community is the most important to apply the green practices. So if you develop the green practices, there will be a new tourists come, those who are actually seeking the green environment. But unfortunately, SME sector, when you look at the SME sector, we can see that the application of green practices on tourism development is so minimal. So my request is, okay, what kind of policies or what kind of strategies we have to adopt to encourage the SME sector. Big sector actually they are doing because they have to follow the guideline, international guideline, but SME sector is the biggest challenge we are facing. Any suggestions, Professor?
Yeah. Again, my main keyword is patience, right? Because you talk about the fast cash because everybody wanted quickly earning money to make you profitable, right? But that cannot be done if you are not creating a sustainable planning mechanism, right? So the patience is really critical because you might invest something today, you may plan something today. Maybe the results would not come in a year 1 or 2. It could come probably in a year 10, maybe year 7, right? But I don't think we have that patience aspect of it to properly plan, design, and implement, right? That's where the challenge in there. So for example, if you look at sustainable tourism, what does the sustainable tourism? I mean, the first question is, what is a sustainable tourism means, and then work towards each element so that we can create a more. I mean, take my example about the regulatory and approval part, right? I gave 3 things in there, right? And similarly, to identify the opportunities of what are the challenges, what are the potential solutions, where are the opportunities for R&D, so that we can start from in a theoretical mindset before we get into some application side of things, right? We have we are actually blessed with our natural beauty and the opportunities that we have as an island, right? I mean, the key is at the end of the day, like what I said on my answer to the first question, having that comprehensive planning mechanism, thoughtful, rather than looking at quick solutions. Instead of the word quick, you cut the quick and say, how do we come up with the sustainable solutions, right? Long way to go. And actually, again, sorry for that. I'm promoting my network here because we have 167 members now within Canada who are willing to work with Sri Lanka on a number of different areas, right? And there are those who are working in some of our places where tourism is quite very well known within Canada, and they could actually partner with whatever the universities, whatever the entities, and to see whether how we can build a more meaningful mechanism and system deal with it. But please get in touch with Sudeepa, and we should have a conversation with you and then with Professor Janaka. So love to have a chat further.
And Professor, I want to add some more thing. Actually, I'm the coordinator of the Sustainable Tourism Unit, Professor Suranga. And what I see is most of the hotels, what they are doing is they are developing the eco lodge in the jungle or some area. But visiting that place and coming back, there are some environment pollution that is not counted by that particular eco site. But they are doing the eco lodge. But coming to that place and going here and there by vehicles and using the natural resources sometimes create more unsustainable activities rather than which is located in the city area. So we have to create that misconception of different stakeholders.
Yeah. No, I actually had a similar recent example when I was in Sri Lanka in December. I went to one of those ecological hotels and I was thoroughly disappointed. And it's not been even very well maintained in there. So I agree with you. So we should further chat. Okay. So I'm ensure that we should further chat.
Thank you, sir. Okay. Thank you very much for organizing this valuable webinar.
Sudeepa, please ensure that we I get any other questions? We have almost come to the end of the time with an hour, but over to you, Sudeepa.
Okay, so thank you very much, sir, for your insightful lecture, and we greatly appreciate your taking time out your busy schedule to share your expertise with us. And we also extend our sincere thanks to all our participants for joining us today. Your engagement and enthusiasm are what make this session so valuable. So please remember that tomorrow is our last lecture in this webinar series, that is Biomimicry in Agriculture, conducted by Dr. P.B. Dharmasena. We look forward to seeing you then as we conclude our exploration of biomimicry for future sustainability. So thank you once again. And yes, sir.